Assalamu alaikum everyone, welcome back to my channel. Today we are going to study model textbook of physics that is for first year of National Book Foundation, and today we are going to study chapter number 6, the short question answers, and the topic is fluid mechanics. So let's get started with this chapter. Moving on to the first question, that is question number 1, which states that why do athletes such as swimmers and bicyclists wear bodysuits in competition? इस क्वेश्चन में हमसे ये पूछा गया है कि एथलीट्स और स्विमर्स जो हैं वो बॉडी सूट्स क्यों पहनते हैं ड्यूरिंग देयर कॉम्पिटिशन्स। तो उसका आंसर ये है, एथलीट्स लाइक स्विमर्स एंड साइकिलिस्ट वेयर बॉडी सूट्स टू रिड्यूस ड्रैग फोर्स ऑन फ्लूइड मैकेनिक्स। जो एथलीट्स होते हैं वो इसलिए वो पहनते हैं वो ड्रेसेस ताकि ड्रैग फोर्स कम लगे। ड्रैग फोर्स का आंसर फ्लूइड, क्योंकि एयर इज इटसेल्फ इज ए फ्लूइड, इट कंटेन मॉइस्चर, ठीक है। तो वहाँ से जो है वो ड्रैग फोर्स को रिड्यूस करते हैं। और स्ट्रीमलाइन सूट मिनिमाइज टर्बुलेंट फ्लो एंड स्किन फ्रिक्शन, ये चीज़ मिनिमाइज करते हैं, अलाउिंग देन टू मूव फास्टर थ्रू एयर और वाटर विद लेस रेजिस्टेंस, एनहांसिंग परफॉर्मेंस। जितनी रेजिस्टेंस कम होगी देयर मूवमेंट वुड बी फास्टर एंड हेंस इट विल एनहांस देयर परफॉर्मेंस। Next is question number 2, which is the distinguish between turbulent and streamlined flow. We have two different flow, that is turbulent and streamlined. We have to distinguish between them. So here's the difference. First difference is nature. The streamlined flow is smooth, orderly, and parallel, while the turbulent flow is irregular, chaotic, and eddies. Yeah, it contains errors. Next is mixings of layers. No mixing between layers. In streamlined flow, the layers are separate, while in turbulent flow, significant mixing of the layers is there. Next is the velocity. The velocity of the streamlined flow is low, while the turbulent flow is high. It moves at the greater velocity. Next is Reynolds number less than 200 for the streamlined flow and greater than 4000 for the turbulent flow. And for the energy loss due to minimal friction in the streamline, as layers are not mixing, there is less friction. Hence, the streamlined flow has minimal friction, while turbulent flow has high friction due to turbulence. An example is water flowing smoothly in a pipe, while the turbulent flow is fast moving river water. Moving on to the next question, that is question number 3, which is when there is change in the width of the river, the speed of the water decreases in the region where speed of the water increases in the narrow region. यहाँ पे ये बोला गया है कि अगर हमारे पास जो पाथ होता है वाटर का, अगर वो कम हो, अगर उसका रीजन कम हो तो वाटर की स्पीड ज़्यादा हो जाती है, वाइल अगर ज़्यादा हो तो हमारी स्पीड कम होती है। तो ये क्यों है, द रीज़न बिहाइंड इट, ठीक है। So the answer is this happens due to the principle of continuity, which states that for an incompressible fluid, the flow rate, area into velocity remains constant. In wider regions, the cross-sectional area increases, so velocity decreases. In narrow regions, the area decreases, so velocity increases to maintain the same flow rate. हमें फ्लो रेट प्रिंसिपल कॉन्टिन्यूटी क्या स्टेट करता है कि जो इनकम्प्रेसिबल फ्लूइड्स होते हैं उनका फ्लो रेट इक्वल रहता है। लाइक इफ द एरिया इंक्रीजेज वेलोसिटी डिक्रीज करेगी, और अगर वेलोसिटी इंक्रीज करेगी तो एरिया डिक्रीज करेगा इन ऑर्डर टू मेंटेन द फ्लो, इन ऑर्डर टू मेक इट कांस्टेंट, ठीक है। तो अगर वाइडर रीजन्स होते हैं, क्रॉस सेक्शनल एरिया ज़्यादा होता है, तो हमारे पास उसको बैलेंस आउट करने के लिए वेलोसिटी डिक्रीज हो जाती है। वाइल इन द नैरो रीजन्स क्रॉस सेक्शनल एरियाज डिक्रीजेस कम होता है तो वेलोसिटी इंक्रीज हो जाती है और हमारा फ्लो रेट ज़्यादा हो जाता है। सो इट्स मैथमेटिकली एक्सप्रेस्ड एज a1 b1 is equals to a2 b2, where a is the cross sectional area and b is the velocity. Next question we have question number 4. It is dangerous to stand close to rail tracks when a rapidly moving commuter's train pass. Explain why. So हमारे पास यहाँ पे कंडीशन पूछी गई है, एक रीज़न पूछी गई है कि अगर हमें एक ट्रैक है उसके बहुत क्लोज खड़े हैं तो why is it dangerous? So the answer is standing close to the fast moving train is dangerous due to the Bernoulli's principle. As the train moves rapidly, the air pressure near it decreases. The higher surrounding air pressure push a person towards the train, creating a suction effect and that can cause the loss of balance and pull them dangerously close. अकॉर्डिंग टू द बर्नौलीज प्रिंसिपल, यहाँ पे बर्नौलीज प्रिंसिपल अप्लाई हुआ हुआ है कि अगर हमारे पास जब तेज़ ट्रेन गुजरेगी तो द एयर प्रेशर जो है वो डिक्रीज हो जाएगा, और जो सराउंडिंग का प्रेशर है दैट इज़ ग्रेटर देन दैट प्रेशर, ठीक है। तो वो दोनों प्रेशर जो है वो पुश करेंगे, द ग्रेटर इफेक्ट जो सक्शन इफेक्ट प्रोड्यूस हो जाएगा, और जिसकी वजह से हम लोग बैलेंस लूज कर सकते हैं एंड वी कुड बी अट्रैक्टेड टुवर्ड्स द ट्रेन एंड हेंस वी कुड be in danger. तो इसलिए जो है it is dangerous. This is the reason for that why we should not stand close to the rail track with the rapidly moving train over it. Next question. That is verify that the pressure has units of energy per unit volume. Here we have to prove the mathematically that the unit of pressure is same as the energy per unit volume. Here for the unit of pressure we know that pressure is the force per unit area, ठीक है, और force है होती है MA, M की unit है kg, and acceleration is meter per second square. So the unit of force is kg meter per second square, and by putting the value of F in the above formula, F is kg meter per second square and the unit of area is meter square. Hence the units become kg per meter and per second square. The meter is cancelled with the meter in the denominator. Hence, the unit of pressure becomes kg per meter per second square. On the other hand, we are going to calculate the units of energy per unit volume. We know that energy or is work. Energy is work done, and its formula is F dot D. The for unit of F as we calculated before was kg meter per second square into the unit of distance is meter. Hence, the unit of energy becomes kg meter square per second square. And volume has units of meter cube, so energy per unit volume becomes kg meter square in per second square over meter cube. The meter square is cancelled with the meter cube, and hence we get the unit that is kg per meter per second square. So by this derivation we can see that the unit of pressure is same as the energy per unit volume. Moving on to the next question, that is question number 6, which states that if you lower the window on the car while moving, an empty plastic bag can sometimes fly out of the window. Why did this happen? ठीक है, हमारे पास ये होता है अगर हम कार में बैठे हुए and we just throw something outside the car, the bag flies out the window. ठीक है, तो वो क्यों होता है? This happens due to Bernoulli's principle and pressure difference. Again, pressure difference and Bernoulli's principle. This happens due to Bernoulli principle and the pressure difference. The explanation is when the car is moving, air outside is moving fast, creating low pressure. जब कार मूव हो रही होती है तो जो बाहर का प्रेशर होता है that is moving fast, जो बाहर का प्रेशर होता है it becomes low. Inside the car the air is relatively still maintaining the high pressure, क्योंकि कार मूव कर रही होती है तो प्रेशर कम हो जाता है, while inside the car there is a higher pressure. So pressure difference create हो जाता है that pushes the bag towards the low pressure area outside, causing them to fly. यानी अगर हमारे पास बाहर जो है वो लोअर प्रेशर होता है और अंदर हाई प्रेशर होता है तो प्रेशर डिफरेंस की वजह से द ऑब्जेक्ट मूव्स टुवर्ड द लोअर प्रेशर, तो लोअर प्रेशर की वजह से जो है द ऑब्जेक्ट मूव्स आउट ऑफ द विंडो. Next question we have, explain how an upthrust is produced when an aeroplane is running on runway. हमने ये बताना है कि upthrust उसको कैसे मिलती है एक aeroplane को when it's moving on the runway. So an upthrust force is a lift force on an airplane is produced due to Bernoulli's principle and Newton's third law. Airfoil shape, the airplane wings are curved at top and flatter below. ठीक है, जो तो ऊपर से curved होते हैं और नीचे से flat होते हैं. This is one reason. Next is airspeed difference. As the plane speeds up, air move faster over the curved top and slower below the wings. क्या होता है प्रेशर डिफरेंस क्रिएट होगा जब ऊपर क्योंकि कर्व्ड है तो वहाँ से जो है वो एयर जल्दी मूव कर जाएगी, जबकि नीचे से अगर हमारे पास फ्लैटर है तो वहाँ से स्लो मूव करेगी. दिस वुड क्रिएट द स्पीड डिफरेंस ऑफ द एयर. Then creates the pressure difference, and pressure difference is create faster air on the top creates low pressure, while the slower air below creates the higher pressure. There creates the higher difference of pressure as well as the difference of speed. On lift generation, the pressure difference generates an upward force helping the plane take off. जब हमारे पास pressure difference create होता है तो हमारे पास the objects move toward the lower pressure, और lower pressure क्या होता है ऊपर वाली side पे, curved वाली side पे. Hence the plane starts to move upward. Additionally, the wing deflects air downwards, and by Newton's law, an equal upward reaction force contributes to lift the plane. Moving on to the next question, that is question number 9, which is why does the ball placed in a vertical air jet become suspended? So the answer for this is when इसमें ये पूछा गया कि अगर बॉल जो है हमारे पास एक वर्टिकल एयर जेट में सस्पेंड की जाती है, so why does it moves upward? So the answer is a ball placed in a vertical air jet becomes suspended due to Bernoulli's principle and dynamic stability. Low pressure regions, the fast moving area around the ball creates low pressure, while the surrounding still air has a high pressure, keeping the ball within the jet. हमारे पास जब बॉल मूव कर रही होती है इनसाइड द जेट, तो वहाँ पे क्या होता है ड्यू टू स्पीड एयर प्रेशर कम हो जाता है, वाइल सराउंडिंग में जो है हमारे पास एयर प्रेशर उतना ही रहता है, हायर रहता है, hence the ball keeps in the jet. Therefore, the upward air force balance gravity suspending the ball and stability. If the ball moves sideways, high pressure still air pushes it back into the jet, keeping it stable in the suspension. जब हमारे पास ball sideways जाती है तो high pressure जो होता है surrounding का, that pushes it again towards the lower pressure, and hence it becomes suspended inside the jet. Next question we have. According to the equation of continuity, if the area decreases, the velocity must increase to maintain the same flow rate. तो जब हम उसको squeeze करते हैं, we decrease the cross sectional area, तो उसको cover up करने के लिए हमारी velocity increase हो जाती है. Hence, flow rate of the water in the rubber pipe increases when we squeeze it. So this is basically due to the equation of continuity. Moving on to the next question.